In question 4, we have the coordinates of the vertices of a triangle ABC are 4, 3, 7, -3, and C is 0.5 and P, so it's unknown. Vertices mean the corners of the triangle. Calculate the gradient of AB. So this is actually a 4 and a 3. So I've drawn up a very rough diagram. Sorry, my drawing is pretty pathetic. I'm using this drawing tool, which I'm not very good at. But anyway, I think you can see it there. So we go on to find the gradient between A and B. So the gradient formula is given by this one. What I've got to do is I've just got to choose one point to be 0.1 and the other to be 0.2. So let me choose A as 1 and B as 2, and I've got to put it into this formula. So for 0.2, I'm going to have y2 minus y1. So this is my y2, this will be my y2, this will be my y1. So I'm going to get -3 minus 3. So that's -3 minus a 3, that's for my y. And this will be my x2 here. This will be my x1. So that's going to be 7 minus 4. So I'm going to get, that's going to be -6 over 3, so it's equal to -2. So the gradient of the line AB will equal -2. Then it says, given that the line AC is perpendicular to the line AB. Alright, so AC is coming from somewhere over here. Now, it's 0.5 is your x value, so it must be coming somewhere like this, but we're told that that angle there is 90 degrees, and C must be somewhere over there. This must be C, and we're just told that this is 0.5 and P, like that. So it says write down the gradient of the line AC. Now they tell us here that it's perpendicular. Remember, perpendicular, this line AC over here is at 90 degrees, therefore, to this line. And the slope of this line over here, if I call that M1, is equal to -2. We've worked that out. Now the formula for when the slopes are, when you have one line is perpendicular to the other, then you get that M1, the slope of the one times the slope of the other, is equal to -1. So if M1, if this one over here, if we call that M1 as -2, times M2 is equal to -1, I'll divide both sides by -2, divide by -2, that cancels. A minus divided by minus is positive. I'm going to get 1/2. So this will be 1/2. And then finally it says find the value of P. Now we've got our slope, so I can go and use this formula over here and put that in. So I've got my slope, which is equal to 1/2, is equal to y2 minus y1, x2 minus x1. So let's call this 0.1. Let's leave A as 0.1 again, but now we'll call this 0.2. So it's going to be 0.2 y2, so it's going to be P minus 3 over 0.5 minus 4. So we're going to get, from this we're going to get 1/2 is equal to P minus 3 divided by minus 3.5. So I just multiply this out. I'm going to cross multiply here. This will be 3.5 minus 3.5 minus, and then I'm going to take, that will give me what P minus 3 is equal to. That equals to minus 1.75, and then I take this over to the other side. The minus 3 over to the other side becomes plus 3. So I'm going to get P is equal to 1.25, or might be my P. P will equal 1.25. Going on to question 5, it says the right pyramid shown in the diagram has a square base with sides of length 40 centimeters. So it's a square base, these are all, and the height of the pyramid is 40 centimeters. When it says right pyramid, what does that mean? Well, it means that this center point, this top of the pyramid is directly above the center, the exact center of that base. Then it says find the length of OB. So we're wanting to find this length over here. Now we're going to be using this triangle then to find that length. Now what a lot of students would say is that PB is equal to 20. But that is wrong. It's not equal to 20. In actual fact, you have to calculate PB, what PB is. And to do that, you would need to construct another triangle here like that. This triangle over here, where this is 20 and that is 20, because that corresponds to half of that and that corresponds to half of that. So PB, let's just say PB is equal to x, you would have x squared is equal to 20 squared plus 20 squared by Pythagoras. So x is actually going to equal the square root of 20 squared, which is 400, plus 400, the square root of 800. And we can just find that out. Let's just do that. The square root of 800, close brackets, that's equal to x is equal to 28.3 centimeters. Now we've got that. Now we have this. Now this, if this is y, we would have the triangle like this. Would have a triangle like that, which is 40. Would have a triangle side like that, and this would be the y over here, where this is 90 degrees. This is 40 centimeters, and this is 28.3. And so we calculate again by Pythagoras, y squared would equal this, actually just y, if I put the square root, would equal 40 squared plus the square of 28.3, which would obviously equal 800, so it's plus 800. So let's just do that. We're going to get shift square root again, and we're going to get 40 squared plus 800, close brackets, enter, and this equals to 48. Y is equal to 48.98, so it's actually equal to 49 centimeters. So we've got 49 centimeters here. Then it says find the angle OBP. So OBP, we're actually looking at this angle over here, which is this angle over there we're going to need. So it's that angle theta there, OBP, that angle over there. So we can use any one of our formulas. Obviously it's a right angle, so we're going to use our SOHCAHTOA angles. This would equal theta. I'm going to use the tan. The tan of theta is equal to, this is my opposite, this is my adjacent, this is my hypotenuse, is equal to 40 over 28.3. So I get 40 divided by 28.3, enter. It gives me about 1.4134. That's a tan of theta. And then to work out theta, I do second function tan, second function of the answer to get that 1.41 number, and I push enter, and it works out to be about 54.7 degrees. I should really write that as 55 degrees because we are given everything to two significant, or actually one significant phone number, so 55 definitely would be accurate enough.